Okay guys, so today's notes on 3.8.5, the three theorems involving proportions. You should have taken notes on those three theorems. I just want to explain them a little more. So you have your side splitter theorem, and that's what you'll call it when you're writing your proof, side splitter. Your parallel lines and transversals proportionality theorem, and your angle bisector theorem. Okay, so those are the three we're going to learn about, or you should have taken notes on. This is your side splitter theorem. Basically what it says is if a line is parallel to one side of a triangle, so like this line here, and it splits the other two sides, it divides them proportionally. So this line is your side splitter. It split this side and it split this side. When you see those two parallel lines, all you do is label. Just start labeling the left side of the figure, split it in A and B, and split the other side in C and D, and write your proportion. A over B equals C over D. It's just that easy. Just A over B equals C over D. You can cross multiply, divide, find your answer in no time, okay? So that's what that means. Then you had the parallel lines and the transversal proportionality. If three or more parallel lines are intersected by two transversals, so here's transversal 1 and transversal 2, the parallel lines divide the transversals proportionally. So that means that you can do the same thing that we did with the triangle figure. It's the same idea. And you set it up exactly the same way. A over B equals C over D. Now this one says three or more lines. So if you happen to have more than three, maybe you have four, pretend I'm doing a good job drawing those as parallel. Okay, and then there's a transversal there, and then there's another transversal there. It's the same thing. If they're all parallel, and there's your two transversals, then A, B, and C, D, E, and F, all those sections still. You could say A over C equals D over F, or B over C equals E over F. It doesn't matter. Just label them and it makes your life easy. You don't have to think about what does the theorem say. And the last one is the angle bisector theorem. So let me go back to the picture. It says this. Let me go back to the theorem. It says if a ray bisects an angle of a triangle, so that's bisected, all right? So they're the same length, are the same measure. It divides the opposite side into segs that are proportional to their adjacent sides. So basically, we're going to say that those two are proportional to these two. So these two sides, these two segments, A over B, are proportional to A is adjacent to C and B is adjacent to D. So if you just go to your opposite side, your side splitter, this is splitting this side, A and B, A over B, and then just do the adjacent to A is C and adjacent to B is D, and you can do that math as well. And there's a lot of problems on the test that will use this, and a lot of problems in the assignment. All right, so those are the theorems. Now we're going to apply them in some problems. So here you have the side splitter theorem where BE is parallel to CD, and you have to find ED, which is this guy, and you have to find CD. So first let's do the labeling. This is A, this is B, this is C, this is D. So we're going to set it up. A over B equals C over D. And we're just going to replace it with 4 over 2 equals 7 over x. You could simplify this if you want to 2 over 1, but I don't think it matters that much. 4 over x equals 14, divide by 4. X equals 7 halves, or 3.5. So that would tell you that that's 3.5. And then it also asks you to find CD. So now we need to find this measure. So you're going to have to use corresponding sides. So you could go back to what we learned about similar figures. 4 over 6 is equal to, now we have to do this whole side over here. Remember, that's the little triangle. This is the big triangle. And we remember that they're similar because they share this angle and the corresponding angles are congruent. Okay, so we know they're similar figures. So 4 over 6 and then That's 4 over 6, and then this is 4 plus 2 is 6 over x. Boy, that looks like a geometric mean right there. 6 over y, pardon me. So that gives you 4y equals 36. Divide by 4. Y equals 9. And so there's a 9. 6 to 9. So it must be a 2 to 3 proportionality there, because that's 2 to 3 as well. All right, so that's how you would do that one. Example 2. Let's say I want you to find the measure of Km. I want you to tell me what this measure is, okay? And I give this information that Kp is 24. Now here here are these givens. I'm going to give you that these are parallel lines, okay? All right, and these are your two transversals. So remember that these are broken up proportionally, okay? So I know that this is 24 because I was given that information. Let's find this measurement. Okay, so this is 715. So it's got a ratio of 15 to 24. So if we find that ratio, then we can use that information for all of these other pieces of information as well. So let's reduce that. 3 goes into that 5 times, and 3 goes into this 8 times. So that means that for every 5 inches you go over here, you go 8 inches over here. So guess what that is? That's 8. If we had to find this measure here, then we could do 5 to 2 equals 8 over y. If you recall, my a over b equals c over d. 5y equals 16, divide by 5. So y equals 3 and 1/5. That would be that measure. And then you could also find that measure. Okay. All right, let's continue. All right, now here's the last one using the angle bisector theorem. Okay, we're given this information that angle RBS is congruent to angle SVT. So that means that this is the angle bisector. So remember what we did. We labeled this A and B, and we labeled this C and D, and we're asked to find ST. So remember, it's A over B equals C over D. So 4 over 8, by the way, it reduces down to 1 over 2, equals C, which is, oops, I made a mistake. Going back, you see what I did, don't you? All right, let's go back. A over B. Oh, I didn't do that wrong. I didn't do that. I did do that wrong. 4 over X equals 8 over 10. Have to be careful there. A over B equals C over D. And I split my side. I got to remember that's my A and my B. So that gives me 40, and that gives me 8x. So divide by 8, x equals 5. So you'll see that they have the same. This was a 4/5 proportionality, so this one has to be 4/5 as well. So got to be careful with that. You saw that mistake I made. Lots of people make that mistake, so be really careful when you label. Okay, so now we're going to use a proof, use this information in a proof. So let's determine, given this information and what we're supposed to prove, which of the 3 theorems we're going to use. And this is a 5-stepper. Okay, so let's start off with XA is parallel to YZ. So that's side splitter right there. So remember, this is A, this is B, this is C, this is D. That's what that information gives us. Now we have also that XAY is congruent to YXA. Hang on a second. Okay, sorry about that. It was XYA, not YXA. So XYA. So we got XAY and XYA. This is the information that we have. XAY and XYA. XAY and XYA. Well, you know what that makes if those two are congruent, correct? That makes these two lines, that makes that an isosceles triangle, even though it doesn't look like one. Okay, that does make XA congruent to XY based upon the picture, even though that looks obtuse and acute. So we got to go with our givens. And when two sides of a triangle, two angles of a triangle are congruent, two sides are congruent. All right, so let's go back to this statement right here. We wrote this as A over B equals C over D. Let's label those, or let's write those as a statement like this. Okay, so let's write it as a proportionality. So A over B would be WA over AY equals WX over XZ. Okay, so that statement would lead us to this statement. Okay, let me stop again. Hang on. All right, you've seen that I've made a big error. I had these 2 points switched. I had the A over here and the X over here, so I apologize for that. Let's just try that again. Thanks for being patient. I didn't want to have to re-record everything. It was already my 3rd recording. All right, so we have our 2 parallel lines. Okay, remember that that's our side splitter. Okay, so again, we're going to go back to that. So let's go write that statement off of this, and then we'll come back and talk about this. So if it's A over B equals C over D, let's substitute that with the actual segment measures. That's WX over XY equals WA over AZ. Okay, so that statement is the side splitter theorem, and it leads us to that proportionality. Now let's go to XAY is congruent to XYA, which looks a little bit nicer. Okay, and this will lead us to the statement that XY is congruent to XA, because if 2 angles of a triangle are congruent, then it's isosceles, so its sides are congruent. Now, if you look at this picture here and this here, there's one difference. The WX, the WX, the WA, the WA, the XY, and the XA, and the AZ and the AZ. So this is a different statement. But if you look here, I wrote that statement. So I can use substitution to write this statement off of this right here. So we've got what we need to do to write our proof. All right, so we would start off with our given. Okay, so there's our given. Our next statement off of that, I wrote right away, was our WX XY equals WA over AZ. And the reason is the side splitter theorem. So you can just write side splitter. You don't have to write theorem. I get it. All right, and that takes care of our first given. Then we're going to go to statement 3, which was angle XAY is congruent to angle XYA. And that was another given. And then we went out of those. That gave us that isosceles triangle. So we said that XY was congruent to XA. And that was statement 4. And we're done because we can take this XA and put it right here for XY, which was that statement there, and we can prove that. So we're done. Oh, wait, let's say if angles, then sides. Okay, now we can write our given WX over XA equal to WA over AZ. B, and we're going to say that this is substitution, but we're going to say where we got it from. Okay, we're substituting number 4 in number 2. So here's number 4, and we're putting it in number 2 right here. And if you kind of circle them, that helps us to see where your substitution is, okay? So there's 1, and there's 1 more. I'm sorry, it's going to go. I'm going to try to get it to go faster. It's another 5-step. All right, so let's take a look at what we've got. We've got parallel lines and parallel lines. So DH, this is point H right here. So DH is parallel to BC. Okay, you know that that means that this is A and this is B and this is C and this is D. It's turned sideways, but it's still side splitter because those are your two transversals. Okay, so we got that information. And then since this is C and D over here, and we have this, that HF is parallel to BG, we've got another side splitter over there. So this would be our A prime, B prime, okay? So we're just gonna call it A prime, B prime, because we've already called these C and D. So I hope you understand why I'm using A prime, B prime, because they're not the same as these ones over here. Okay, excuse me. And now what we're gonna do is we're gonna try to prove that CD over DE is equal to GF over FE. And let's see how we can prove this. Okay, so we're just saying that they are proportional. Well, if we work off of this statement right here, we could say that CD over DE is equal to BH over HE. We can say that. So that's that statement. And then this one here, this one gives us the statement that GF over FE is equal to BH over HE. And so these BH is equal to that and this. So we can use the transitive property to say that these two are congruent to each other, are equal to each other, which is what we're trying to prove. So pretty much we're done with that. So we can say our first statement that DH is BC, and that's a given. And then number 2 would be our CD over DE equal to BH over HE. And that's side splitter again. And then number 3, that takes care of that given, our other given, HF and BG. So those are parallel lines. That's number 3 given. And then number 4, we would state the information coming off of that, GF and FE, and BH and HE. And we could say same as 2. And then number 5, because we see that twice, we can set their quantities equal to each other. CD is DE and GF is FE. And that's the transitive property. And this is putting 4 and 2 are the ones that we're combining. And notice I circled. Okay, and that's all I got. So hopefully that helps. Have a good afternoon, guys.